Ladies and gentlemen, hello and welcome to this edition of our global webinar series. Today's topic is electrically driven compressors. My name is Alexander Nebel. I am Field Application Engineer in Europe and I will moderate the webinar today. We are very pleased that you find the time to join our webinar. Presenter today is Maawad Makdessi, our Field Application Engineer in Western Europe. With this information, I hand over to Maawad. Hello, Maawad. Thank you for your time today. Please tell us a little about yourself before you begin your webinar.
Hello all, and thank you, Alex, for your introduction. As you have mentioned, my today's topic is related to the electric compressors used for electrical vehicle. And let me first introduce myself. So my name is Maawad Makdessi, and I have been with KEMET since September 2018. And I have joined the team as a field application engineer to provide the technical support to our customers located in the west of Europe. Here is my agenda for my today's speech. So at the beginning, I will briefly introduce the operating principle of an electric compressor and show its equivalent circuit diagram. And then I will focus my presentation on the solution that we can provide from our portfolio regarding the EMI filter and the DCLink capacitors. And finally, conclusions and takeaways. Why we are focusing today on the compressors in my today's presentation is mainly because the compressors are playing a crucial function within the air conditioning system of a vehicle. They ensure the compression of the refrigerant fluid and its circulation within the air conditioning loop, which will ensure the temperature cooling within the cabin when needed. However, the conventional compressors have a main drawback, which is what we see here in the drawing, is that they are continuously connected to the engine crankshaft via a belt drive. With such configuration, you can imagine that the compressor cannot be operating without the engine in an operating mode, which limit its function and its usage when talking about electric vehicle and hybrid vehicles, because they have different operating state than the traditional or the conventional internal combustion engines. They have a stop and start, recuperation, or regeneration phase, and all of these different states cannot be operational with this compressor. For this reason, a different solution have been proposed, and that is the electric driven compressors. So what is the main difference between the conventional belt driven compressors and the electric compressors is related to the way or how these compressors are powered. So on the left side, we see the belt-driven compressor, the conventional ones, and on the right side, we are showing the electric compressors. And we see that clearly the difference is between the way we are powering these compressors. The electric compressors will be directly powered from the battery, and whereas the belt-driven compressors are powered from the engine and connected together via a belt drive. So since the electric compressors will be directly powered from the battery, which is in DC, we need in this case to place an inverter to convert the DC power coming from the battery side to an AC power that will be able to run the motor within the compressor. So the main benefit from moving from the belt-driven compressor to electric-driven compressor will be the fact that the electric compressors will be operating independently from the engine, and also since the inverter will control better the motor run of the compressor, we will be optimizing the motor speed and enhancing the power efficiency of the electric compressor. So at the end, we will be saving the power and enhancing the efficiency of the electric compressor. But let us see the overall block diagram of the ADC. So there is different parts of that make the ADC work correctly. But here we are showing all the stages. So we have the battery that will be connected to EMI filter to filter all the noises coming from the battery and also from the inverter side. We have the DCLink stage, we have the inverter, and then the motor drive of the compressor itself. So generally, we have here a PWM inverter that controls the three-phase motor, and generally the motor will be a BLDC motor. And today we will focus on the solution that we can propose from our portfolio regarding the EMI filter and the DCLink stages. Let us first start with the EMI capacitors, and we will start with a few words to describe this technology and this family of products. And generally, they are called safety capacitors or EMI suppression capacitors. And this different classification of these capacitors is related to the way that these capacitors are connected to the circuit and to their safety level or the level of voltage that they are designed and certified for. So generally, we have international certification and standard that we follow, and we define these capacitors, following these function or characteristics. So mainly, if the capacitor is connected between phase to phase or phase to neutral, in this case, we will be talking about differential mode capacitors or X capacitors. And if the capacitor is connected from phase to ground, in this case, we will be talking about common mode capacitors or Y capacitors. And then from these X and Y capacitors, we have what we call subclasses. That means that inside these X and Y capacitors, we have a different level of protection that are defined for these capacitors. So the X2, X1, Y2, and Y1 is what we have today in our portfolio. Of course, there's also other levels like X3, Y3, and X4, Y4, but we will not be talking here about them. And the level of these subclasses is defined on based on different internal tests. That means we test internally the parts to be supporting or compliant with the standard levels, like the flammability test, the impulse test, and the endurance test. And each subclass will follow the internal rules of the standard. So the highest protection that we will get is with the Y1 capacitors that have a peak impulse voltage of 8 kilovolt, and the X2 capacitors, for instance, will have a 2.5 kilovolt peak impulse voltage. Some substitution can be done between these subclasses. So for example, we can use a Y1 or instead of X1 because it will be having higher peak values. But for such substitution, we need to be careful and check each of the differences between the subclasses. So today, the main drivers for our roadmap for these EMI capacitors are really the ambient or the ambient temperature, and the capacitors are more and more required to be able to operate in harsh environmental conditions. And so in addition to the AEC Q200 requirements, we have to follow now what we call the THB test performance that is defined in the IEC 6384-14, where we have the definition of the protection against humidity. So we have 3 grades and 2 conditions A and B, which lead us to 6 configurations. The most stressful or harsh stress would be in the grade 3B, where we have to withstand the 85 degrees, 85% of humidity for 1,000 hours at the rated voltage. And the capacitance must not have a drop more than 10% of capacitance. And the most easy test, let's say, or less stress test is the grade 1A. In this case, the capacitor must handle 40 degrees, 93% of relative humidity for 21 days at the rated voltage. So what are the new series that we are developing today to follow this trend? Recently, we have released a new series that is the R52 and R53 as X2 capacitors and R41T for the Y2 capacitors. This table summarizes the different series that we have. So for an easy selection between the series, the latest series, and the series that must follow the ECQ200 and the THB test are listed here. You can directly select the correct series, and that is most suited for your application. And for the electric compressors, we know that the stress on the capacitors are related on their position in the compressors. That means if the inverter is placed outside of the compressor, in this case, the capacitors may endure a high environmental condition stresses. Whereas if the inverter is integrated within the compressor, in this case, since it's hermetic sealed, the capacitor won't see high environmental stresses, but the miniaturization is still needed here. And this is why the R52 and R53 are important for this kind of application, even though the humidity or the THP performance is not needed. We will show later what is the difference with the standard series. But let us have a look on the R52 series. Here we are showing the characteristics of this series in terms of capacitance, in terms of lead space or pitch size. And we see that we are covering a capacitance range from 100 nanofarad up to 22 microfarad. And we have this capacitor THB grade 2B. That means it is able to handle 85 degrees, 85% of relative humidity for 500 hours at 310 VAC. You will notice also that for these capacitors, we are now showing the DC capabilities of the series, and this is mainly due to the application of these capacitors in DC application, like the one for ADC, which is directly connected to the battery and not to the main. It is interesting to notice as well that these capacitor series is first to market, that is proposed by KEMET, and this is a combination, proposing a combination between the miniaturization and the optimized performance from an electrical point of view. But when we talk about harsh or robust construction and able to support or to operate in harsh environmental conditions, we will give you a quantitative data to let you know and understand what is the main difference between these series. So what we are showing here is the capacitance drop that we are plotting between the R52 series compared to a standard series, the R46, which is not designed to operate in harsh environmental conditions. And both series were subjected to 85 degrees, 85% relative humidity, and 240 volt AC. And we clearly see in this graph that the R52 series will be or may be having a really stable capacitance drop with time. Up to 1000 hours, we will not reach even 5% drop, whereas the R46 series will have a really fast drop of capacitance, and almost after 250 hours, we will reach more than 25% of drop of capacitance. The other series that will be recently or soon released is the R53. And from a mechanical point of view, so the R53 will have the same mechanical dimension as the R52, and the main difference will be rated on the THB performance. So the R52 will be grade 2B, whereas the R53 will be grade 3B. That means that it operates at 85 for 1000 hours at the rated voltage. For the same reason as I explained before, since now the applications are meant in DC and targeting DC application, we are now having also the test of THB when supplied with DC voltage and not always with AC voltage. So we will have both, and this is a sort of test to comfort or to prove the compliance of these parts when subjected to DC or AC, and in DC, which will be more close to the application in this kind of application. The R53 is also first to market, and it is combining even better performance than the R52. So we will maybe ask what is then the difference between the R52 and R53, and when we need to use one of them. And the answer is really easy, and depending on the application of the user. If the application do not require this high level of THB performance, the R52 will be the most suited. So to give you an idea about the miniaturization and the different or the enhancement in performance compared to our previous series, we selected the same capacitance value, same rated voltage, and we have defined part numbers from our previous series, the F862, and compared their dimension and the THB performance with our R52 and R53 series. And we can clearly see that for the same capacitance values, we can reach them with a smaller dimension and even with a smaller pitch size with the R52 and for R53 series, and will have at least the same performance as the F862. So we will have a clearly better performance, overall performance with the R52 and R53, even with our internal series. In order to be able to be sure and to verify that our capacitors are compliant with your mission profile and the application requirements, KEMET have developed an online web tool that allows the user to directly check and include the mission profile and check if the part number that have been selected is replying or is handling the application requirements. So this is a first to market tool because it is the first manufacturer to put this kind of online tool. And also it's the first time that we have this kind of aging laws. Generally, the aging laws that we see and are clearly and are developed in the market are the aging laws that are only dependent from voltage and temperature, whereas this new model will be taking into account also the temperature and the humidity and the THB performance. So today, these 4 series are already included in the KLM tool, and for sure, other series will be included in the next months. So here is the website or the link to the website where you can find this online tool, and you can directly integrate your mission profile. The most important thing is that the total of the working time will be 100%, and then you need to put for each working time what is the operating voltage, the ambient temperature, and the relative humidity. And as an output, you will directly get the capacitance lifetime estimation, and the capacitance drop of 20% was taken as reference. Once the mission profile is identified and fixed, you can select different part numbers from different series and different pitch size and check what would be the best part number fitting within your application. Now we'll move to the magnetic part. So we're still in the EMI filter, but we will talk now about the differential mode and common mode solution. So considering the differential mode solution, today what we can propose a differential mode choke for the electric compressors are clearly our MPEV Series, which are a metal composite inductors that are optimized in terms of losses to get the highest current capabilities. So the fact that our MPEV series are metal composite, that means that they have a distributed air gap inside, which will enhance the current capabilities and increase their saturation capabilities. Here is an overview of the different capacitance value that we can provide. So here we are plotting the inductance values that we can propose related to the rated currents and for different footprints and heights. So you can directly select the correct part numbers and see if we have solution for your application. So the footprint, the standard footprints up to now are from 5 by 5 up to 22 by 22. But there is a new extension of this series that will be released soon to go down to 4 by 4 and to have more inductance value to cover. An important point to highlight is the temperature, since for electric compressors this is an important parameter. So our MPEV series can handle from minus 55 up to 155 degrees. And our SMD parts solution. But it is not, we will not have this only, this one only solution. We have a new series that will be coming soon. That is the MPEV series, which is ASUC300 as well. But the main difference would be on the operating temperature. So this series, the MPEV, will be able to handle up to 180 degrees Celsius. And here we are showing you a slight overview of the different values that we can provide in terms of inductance and currents and case sizes. So basically we will have two case sizes, 6 by 6 and 10 by 10 millimeters. So stay tuned. We will for sure communicate on this series once it is available for launching. When it comes to a common mode solution, we have different materials that we work with, and also that we develop ourselves. So this is an important point to highlight here, is that we produce most of our magnetic materials, ferromagnetic materials, and for instance, the denomination that you see here, the manganese zinc series, is our internal nomination, and this allows us to optimize and to get the better performance that we can get from the material itself. So we have, for example, the 5H, 7H, 10H, and also new releases for higher temperatures, 5HT, 7HT, and for industrial or high permeability material, we have the S15H and S18H. Of course, we have also material with nickel zinc and non-crystal materials as well. So the main difference is related to the application itself, and we will choose the correct material for a given application. So if an application is more focused on the high temperature, for sure we will be selecting more the high temperature materials, such the 5HT and 7HT, and we are working on the 10HT. And if the temperature is not the most critical part and we are more focusing on the miniaturization and increasing the power density, in this case, we can provide solutions with our S15H and S18H. And just for your information, when we compare the permeability of these materials with the existing one in the market, we will have 13 to 40% better permeability than the one existing. So what are the solutions that we can propose here? If you look on our website and check for automotive solution portfolio, you will clearly don't see too much products, and this is related to the fact that most of the cases we are working on customized shape and designs for these kind of applications. But recently we will be releasing a new standard series for automotive application to have better availability and for the designs to be directly selected and designed in. So these series are based from the different inputs that we have from the market trend, and we basically have three families. We will have three main families depending on the diameter and shape of the material and the common mode choke, and also related to the material itself, the temperature that need to be operating, and the current rating. Here you will notice that we will have a specific shape here, which we call the dual mode design. That means with this design, we will be able to combine the common mode chokes and the differential mode chokes with a unique and single design. I will not spend too much here on the part numbering, but this is an overview of the part numbering that we will have in our new releases of common mode chokes for automotive applications. And you can check it later on, but it will be related on the material, on the diameter and electrical parameters. So for the DCLink, for the EDC or for the electric compressors are really crucial, selection of the correct family product and technology is really important to be optimizing and ensuring that the capacitor will handle all the application conditions. So the DCLink, of course, will be need to be selected to drive or to filter all the RMS current coming from the power modules and also from the battery side. The capacitance value need to be correctly dimensioned in order to filter the RMS voltage that can be on present on the DC bus voltage. At the same time, selecting a high capacitance value is not really helpful when targeting the miniaturization of the ADC and optimization of the mechanical design. So the capacitance value and the capacitance family is really crucial for this function of the circuit. From the different topics and specification that we worked on the market, by far the film capacitors will be the best technology to go with for this capacity, for this function, and mainly for the DEC for high voltage. The C4QM family would be the best family to select. Of course, the C4QM is not a new series that we have, but we have made some extension with the series and some enhancement, mainly with the temperature. So now we have the C4QM with a possibility to be operating at 125 degrees for a limited number of hours, and we also have the low profile configuration. And with these two enhancements, we think that it is very appropriate to be selected for the DCLink of the electric compressors. The new series that we have recently released is the C4QM. So the M and the part number will be standing for the miniaturization compared to the C4QM series. So the main difference, of course, would be on the mechanical size. That means we will get better capacitance efficiency with a lower total volume. all the other parameters will remain the same in terms of THP performance and in terms of temperature performance. But let us look deeper on this comparison between the C4EQ and the C4EQM. And if we compare from a mechanical point of view, we'll be able to reach up to 28% on the reduction of the volume and up to 29% of the reduction in the PCB surface area. For some capacitance values, we will be able even to reduce the capacitance and to move to a lower pitch size. And here we are showing some examples where we can move to a lower dimension of the case size, the same capacitance value and rated voltage. When it comes to environmental capabilities, so both C4EQ and C4EQM are, of course, ACQ 200 certified. And in terms of THB performance, they have better performance than the requirements of the ACQ 200 test. So we have 60%, 95% of relative humidity compared to the 40 degrees and 93% of relative humidity required by ACQ 200. At the same time, we will have a better capacitance drop than the required one in the standard. So when now we compare the C4QM to the existing solution in the market and take, for instance, a competitor A, which is well known in the market, we see that by selecting the same capacitance value and same rated voltage, we will have a better volume and PCB area. That means we will have almost 50% better volume than our competitors, while keeping the same rated current. This is what we are plotting here, because normally the current and the volume are dependent from each other, because the RTH and the thermal dissipation are related to the mechanical size. So by reducing the mechanical dimensions of the capacitor, we will be keeping the same RMS. And this is very important to highlight, because we will have better current capabilities than our competitors. And the main difference is coming from the maximum self-heating capability that we allow for this series. And if we compare here the self-heating capability of the C4EQM with our competitor, we see that we allow a higher delta T, which make this difference. Another point is related to the temperature. As I mentioned, this series, the C4EQ and C4EQM, will have the capability to operate at 125 degrees, but it is in a power off mode. That means no current, no voltage need to be applied at this operating condition. When talking about miniaturization, the main benefit will also be on the ESL, or the parasitic inductance. So when miniaturizing the capacitor, we will enhance this parasitic inductance, and the capacitor can operate at higher operating frequencies. And this is what we have made here as a comparison between the C4EQM between this series and our competitor B. But in general, when we talk about compliance of the DCLink capacitor with an application, we generally talk about emission profile. And generally, we receive the emission profile from our customers with the maximum information that are needed on the capacitance, voltage, the RMS current flowing inside the capacitor, the harmonics, the temperature, duty cycles. So any information that is useful with all the mechanical aspect, if there is cooling or no cooling. And then we will have internally some softwares to simulate all these parameters and evaluate the lifetime of these capacitors. And then we can provide samples with thermal probes and to compare the simulation to the experimental data. So these softwares are already existing internally and will be soon be on the website. for all users. But today, if you have any kind of request of this type, please get in touch with your local FAEs and technical product managers, and we will for sure provide the required support. On this slide, I will show you the DCLink overview of our different families that we have. There's existing one, so all the blue ones are existing series already launched, and the gray colored series will be recently released or will be soon released in the Q1 2021. And to select the right DCLink family, you have to be focusing on two main parameters: the maximum operating temperature, for how much long you need to operate at higher temperatures, and what are your application THB requirements. And once you have these two requirements, you can directly select the right capacitance series for your application. Let's take an example. If you have requirements for the electric compressors that need to operate at high temperatures, 125 degrees, but you don't need requirements in the THB or robustness because it is integrated in the compressor and it is hermetically sealed. So in this case, the C4QP would be the perfect series for you. Whereas if for the same application, but the inverter is placed outside the compressor, and in this case, you need to operate at high temperature for a long time, and at the same time to have the THB performance. And this is, in this case, probably the C4AK series would be the best solution for your application. And with this, and I have finished my presentation, and I'm open for questions.
Yes, thank you, Maawad, for this presentation. It was quite interesting, and I hope to all the attendees you also enjoyed it. We are now in our Q&A session. We are a little bit over time. There's still time to answer some of your questions, so please use still the Q&A function to enter your questions. And we have already one question. Do you offer some cooling concepts for the shown capacitors? This is not linked to a slide, but it was around slide number 35. And then there was the comment, a smaller part could be selected if the cooling could be optimized. So it's about the cooling process, if we have some special...
Yes, we have some cooling concept, but not with the C4AQ. So for the C4AQ, we can have only the part and recommendation how to make the cooling. But for different family series, like for the electrolytic capacitors, the PEG series, the actual series, we will be recently or soon releasing a new concept of capacitors with the cooling system. So stay tuned. We will be recently launching this concept.
Okay, so I hope this answers your question. But if you have still questions, you can contact me directly. Also, I can see you are one of my customers. Okay, so this is for the moment are all the questions. I think this is a good sign that shows that your explanation was excellent to the customers. And as now the time is already running ahead, I want to say thank you to the attendees for joining today. Please also look in our upcoming webinars in the next weeks. Thank you, Maawad, for presenting today. It was quite interesting. And yes, I hope to see you soon again.
Thank you, Alex. Bye-bye.
Okay, goodbye.